Good morning, mathematicians. How we all doing today? Have you had your fill of my live streams? Having streamed for 8 hours yesterday. Good morning, mathematicians. One would think that perhaps you have, but then again, maybe you're here. So yesterday, if you tuned in, there was a long section where there is debate about set theory and whether you can do category theory in ZFC or not, roughly speaking. So there's some interesting things to discuss about that. I have I made a Stack Exchange post, which we'll come to in a second. And good morning, head empty set. So there's no answers, but there are some comments. We'll come to that in a second. First, I want to go to Discord, because I asked in a set theory Discord. Maybe I should shrink this. Arguing about set theory. Oh boy. Good morning, mathematician Boris. Well, I think this Discord discussion highlights part of where the disagreement comes from. So I asked the question. I linked the video. I linked the Stack Exchange post. And so here I think is an important point about maybe the nature of our disagreement. Is that in ZFC the notion of definable class? There's a notion of definable class. Oh, thanks, Mom. Thanks, Mom. Well, today's definitely not going to be 8 hours. Today will maybe be an hour. And then I got to go to the airport. Let me plug in here. Your Reddit post advertising my stream got deleted? Yeah, I didn't see it. That's too bad. Why would it get deleted? I'm pretty sure I've shared videos on Reddit before. Whatever. Mods are dumb. You can tell him I said that. Send him this video. That's a charity fundraiser thing. I mean, okay, whatever. I guess I'm making money too. Not that much. It's not like there's even that many views on it. And besides, maybe they thought you were me and I was being too much self-promotion or something. I don't know. Right. So like in NGB, classes are first class objects, so you can talk about them directly. But in ZFC, there's a notion of definable class. And I think this is getting at the heart of our disagreement, what we were talking about yesterday, because I think this is what Arad and Leo were talking about, is having the convenient language to talk about formulas and referring to those as classes. But here there's a distinction made between definable class. And then good morning, Arad. Good morning, Arad. I was just highlighting. So I've had some discussion in set theory Discord. This is definitely what you meant. Yeah. So, but I'm also unsure of to what extent this resolves the issue, right? So, because like he mentions here, this is similar to how you can talk about the set of prime numbers in Pinot arithmetic, even though first-class infinite sets are not first-class objects in Pinot arithmetic. So technically, there are no sets in Pinot arithmetic, right? Well, infinite sets, I suppose. And yet, I mean, having a definable class, having like the set of prime numbers being numbers defined by this formula, which he gives below, you know, so like this statement, he gives the example of like this statement of saying for every integer, there's a prime number bigger than it. This is essentially equivalent to the statement that the set of infinite prime of the set of prime numbers is infinite. Although, if we're strictly technically speaking, you couldn't construct the set. So I'm not exactly sure what this entirely means for our discussion. Because this makes sense to me. Yeah. Model theory is dope, and you love it. Maybe we should do more model theory. Maybe we should do more model theory on the stream and learn logic together. But I'm also thinking like, kind of want to look at some number theory because my friend was just messaging me about number theory. After, but let's go through some more things here, because I think this is there's interesting things to discuss. Yeah, so I guess the rest of this is just me asking for clarification on these points. Right. So then I mentioned though, you agree, and Leo too, that if you get far enough in category theory, you'll have to introduce some sort of large cardinals, but it's not necessary just for defining functors. Yeah, I guess it depends on how one conceives of as a functor, right? It depends on how one conceives of a functor. Because one can define a formula, I suppose. One could define a formula on, say, the collection of all sets. Right? And so in that sense, I suppose one could define a functor, right? In that sense, one could define a functor. But to form... So I agree with you there. The notion of a functor could be defined in terms of the formula that describes it. But in order to construct, like, to have a functor as an object, in the same way that in Pinot arithmetic, one can technically define the set of prime numbers using this formula that defines the prime numbers. But one cannot instantiate the set, set as a first class object in Pinot arithmetic. Pinot arithmetic. Right? And I guess this is a strange philosophical point. But actually I have another thing to say about that. Very ignorant about number theory. Also, more reason to learn number theory. Your prof loves defining everything with just growth and deque universes. Yeah. A functor on set would be analogous to class functions, often used in set theory. But what do we mean by class functions here, right? A function... a function, so some sort of definable formula, because then, like, if we're being super literal, a function should be a subset of the Cartesian product, as we discussed yesterday. But okay, I guess a class function we could also take to mean we could avoid actually instantiating classes as first class objects, and we could define them by a formulae. What are countably infinite and uncountable sets? Basically, the integers and rational numbers are countably infinite. Countably infinite means you can be put in bijection with the natural numbers. Uncountable means you cannot. So the real numbers cannot be put in bijection. So actually, I do have one question, though, for you and Leo. And maybe you've already answered this, but I do have one question which I did ask yesterday, and you don't have to respond immediately in the comments here. In fact, if anything, I'd prefer a more thought out, like whatever. I mean, unless you have the answer right away. But then, in your opinion, what is the purpose in the infinity category book that they introduce all of um, the growth and Deke universe at the very beginning? What is the main function of that? Um, yeah, that's what I'm curious to know then. But maybe you don't have an opinion because maybe you feel like you need to read the book in order to actually know. Maybe they say it in the book. Maybe I should go back in the book and read what they actually say. Right. So then I mentioned here I'm still confused for what this means about category theory in ZFC. Does this mean I can define categories such that a collection of objects is a definable class? And how do I phrase that without invoking proper class? And so here's actually the other important point about maybe the nature of our disagreement is less mathematical than any of the three of us believe, because there's this point here that it's a slightly philosophical question, which I think, again, comes back to this point of what does it mean to define a functor? And so we can define a functor through the some sort of formula, and I agree with this. But then, what does it mean for that functor to truly exist as a first class object? Well, then in that case, we would have to describe it as a set, which is now we would have to commit to something beyond ZFC. So, but I think this is a point of philosophy in some sense, where I think you and Leo are content to simply define a functor by this formula. And not to say that I'm uncontent for this as well, but to think of like a functor existing as an actual object in the theory. I think we're going beyond. When people say the word category, they usually allow objects to form a proper class. There's a specific name for when they form a set, a small category. Yes, right? But this is also part of the point. A proper class is not within ZFC. Like, you can't construct, it's part of the meta theory. It's part of the meta theory. But like, let's say, for example, that I only want to philosophically commit to objects that exist if they can be proven to exist within ZFC. Just say, right? Then I could not talk about the proper class of all sets because I cannot construct that from the axioms of ZFC. Now, maybe you disagree with that philosophical commitment, but I'm partial to this point of view. And I have one point at the end of all of this that I'm going to make in a second. Not in a second. I wanna peruse through. We're gonna go to the Stack. We're gonna go to the Stack Exchange post in a minute. But I do have one point. I'm saving it for the end. Maybe you and Leo won't like it, but but you'll see. So then I asked about places we can read more about it. As far as I know, no one has written down a careful treatment of category theory in ZFC. And it would be better to phrase it in NBG anyways. Specifically, given any theorem of this sort, you have a corresponding theorem schema in ZFC. So it's actually better to work in this, even if you're philosophically reluctant to commit to a proper class as an object. Yeah. But yeah, basically, there's a lot of boring bureaucracy, and it's not been written out carefully. Um, this is really funny because you set theorists use proper classes all the time, largely without a care in the world. Yeah, I have no, to be clear, as I say in this comment, I have no problem with proper classes, and I have no problem with growth in Deek universes. Although technically, I, I, I have a slight preference for not using growth in Deek universes. Or sorry, for not using proper classes and taking like an infinite hierarchy of cardinal inaccessible cardinals. Who cares about ZFC anyways? Well, let us know when you make that set theory, Boris. Let us know when you make that set theory. We'll live stream the first learning session with that set theory. But then you can go back to the example of primes in PA. Your philosophy would imply that you can't make any claims. No, it would not imply that. I disagree. I disagree. I'm not saying that. I'm not saying that. We can make claims about primes. 100%. 100% we can prove things about primes. We could even prove something about all primes. That would be totally fine. That would be totally fine. Because every single so I'm okay with you and Leo quantifying over these formulas, having these formulas. That's fine. That is absolutely fine. But I just wouldn't be okay with a statement that says let P be the set of all primes. Right? Why am I awake? Because there's coffee to be drunk. This coffee ain't gonna drink itself. If you know that f of x equals 1, we are doing post-fight analysis, yeah. If we know that f of x equals 1, and x is between 0 and 1, and 0... Oh, so you have some piecewise function here. You'd want to find the functions describing the behavior of y. Find the function f sub y. Describing the... I'm sorry, Matthias, I'm not sure I understand your question. Is this that early? I've streamed earlier. Where's my water? One sec. Yeah, so let's maybe keep moving ahead through some of the points that were made. There's some other discussion, Leo. I mean, you can watch the first part of stream after, I suppose. Let's see. Okay, and then there's just something about the NGB thing. So you get that it's a piecewise function. You wrote the value of f of x and the associating condition. I'm not sure I understand. How would I find f of y? You just plug EX into there? I'm not sure I understand. Oh, um, yes, I agree with you. I agree with you, Leo. And I've even, I guess you missed this part of the stream. I even agree. You can define the notion of a functor in the sense that you can write down a formula that applies to all sets. I agree with absolutely every part of this. No disagreement there. No disagreement there. Sorry, Matthias. So you have this, and this. So f of e to the minus x is just 1 when e to the minus x is greater than 1, x when e to the x is between these two things, and 0 when e to the minus x is less than 0. Sorry, minus x. And now you just need to do some math with ln to figure out when this happens. But I think that Arad and Leo are trash blue people who should die horribly. Yeah, exactly. Exactly. Good recommendation for graph theory, which is graduate level. I actually like. I have a book review coming out Friday. I've reviewed some, well, technically undergrad books, but if you're of the algebraic persuasion, I really like Godsill and Royal's book. I really like Godsill and Royal. Godsill and Royal. Algebraic graph theory. It introduces, it talks about the basics of ordinary graph theory, but, other common ones. I mean, you could read it as grad or undergrad. These distinctions are not always meaningful. There's Diestel. There's Bolabash. I don't know how to actually spell his name. There's a fire additive combinatorics course on MIT. Well, there you go. Right. Okay. So let's go over the Stack Exchange post now. So I asked. Well, we saw the question. Asked yesterday. You can always go find the Stack Exchange post. So then this person says, you can do category theory perfectly fine in ZFC. You just have to adjust the definitions and pay attention to size limits. Most mathematicians, even or especially category theorists, find this too much effort for not much gain. So then I asked about how to discuss the category of sets, because a collection of objects is too big to be a set. And so I have to introduce a proper class or a large cardinal. How would I do this? How would I do this in a way that does not constitute going beyond ZFC? So then he says, you have to adjust the definitions. So obviously you have to consider a smaller category of sets. So it seems from this random person that the category of sets as we normally understand it, you can't do it. You have to make an adjustment to the category of sets. Is not necessary to assume large cardinals, but obviously you'll have to make some sacrifices. So then I asked for clarification, because it seems to me that he is saying that I then have two choices. That either I can do category theory within ZFC, but at the cost of a smaller category of sets, which I would say then means we can't form the category of sets as we normally think about it within ZFC, or I'm forced to leave ZFC. And he said basically. So, um, he's not doing what Arad and you were talking about. No. It seems like he's closer to my side, right? Because his statement seems closer to my side. Now, interesting, he does say to go look at how Stacks Project defines the category of schemes. So let's go over to Stacks Project. This next part I don't think will resolve anything in any way. But let's go look at the set theory. So in particular, tried to trick me into doing probability question. Well, I don't think it's not clear. It's not clear that anything what you said has to do with set theory or probability theory. Sorry. Okay. So at some point they say everything is a set. Then we go over to classes. Right. So, but I think both things are true, right? And maybe this is again part of the confusing part of our disagreement. Because some proper classes, as was said in the set theory server, right? Some proper classes can essentially be talked about without actually instantiating them in your theory, right? Definable classes. And one can technically get away with this without actually having to commit to the existence of proper classes. Right? That you wanted to make is that you can do a lot of category theory. Okay. And in practice, we do a lot without assuming. Okay, so then this I would agree. Then there's no disagreement. If you say we can do a lot of category theory, then I agree with you. But I would you just use formulas. But you can't form the class of all sets though. You can't form the class of all sets. I mean, as this guy is saying, there's two things. So you can do category theory within ZFC by making augmentations at a cost of some smaller cardinals, or you can introduce larger cardinals. But let's also see. My final point is still coming, though. My final point is still coming. You're gonna hate it. My final point is still coming by the end of stream. PhD applications are due tomorrow. All of them? Struggling to write why you want to go to XYZ university /interest when you really don't know what you want to study yet in math. Yeah, I don't know. I think it's okay to say that. I think it's okay to say something. No, Leo. I think you're mischaracterizing what I'm saying there. I think you're mischaracterizing what I'm saying there. But let me answer this other question. So for the PhD applications, the thing is, I think it's perfectly fine to essentially say that, is to say, look, I did well in these courses. I enjoyed these courses. I'm interested in geometry and representation theory. I was looking at so-and-so professor's webpage and so-and-so professor's webpage, and these seem like things that I, am interested in, because I think that most people understand that you, as an end of year end of undergrad, I think most people understand that you don't actually know what you're talking about in any of these regards, right? I think most people know that, yeah, probably you generally understand, you get the tip of the iceberg of geometry and representation theory. You know enough to be interested, but that you really have no idea what actual research in the area is going to be like. I think this is true for the majority of people applying to grad school, and I think most people in reviewing your applications are going to be cognizant of it. So you can be honest about that. I mean, I wouldn't say I don't know what I want to study, but just be like, yeah, I'm kind of like interested in this thing and that thing. So I will, as I often do to people, point you to Angela Collier. Your statement sucks. I know this isn't your personal statement sucks. Yeah, go watch that video. Yeah, go watch that video. So what am I saying? What am I saying? Yeah, go watch that video. Oh yeah, but I was gonna say this isn't Jacob Collier's relative. I don't think so. I think Collier is a pretty popular last name. I think. Oh yeah, this isn't gonna help you, but it will help other people. Don't wait. Make sure you have all your applications basically done like the day before, or get them done a lot earlier than the day before. So let this be a warning to others. Yeah. But yeah, I don't know. I hope that's maybe enough to go for. So again, Leah, and I guess you missed this part of the stream where I was talking about there is a subtlety in what we mean by define. And so I think there's a philosophical difference here. And so I do I agree with and this is something I didn't quite understand before. I do agree with you and Arad that we can define a functor in the sense that we can like write down a formula which we could pass all sets through. So I agree with you that we can definitely define a functor in that sense, and you know, such a formula which satisfies the conditions of a functor. So this I agree with. I have no problem with that, right? We can define a functor. However, a functor defined in that sense cannot be treated as a first class object in the theory, right? So again, with this analogy of the prime numbers, one can define what it means to be a prime number, and one can, in piano arithmetic, and one can prove something about all prime numbers. This is absolutely fine, right? And one can, therefore, one has a definable formula, and often as a convenience will refer to the set of all prime numbers. Although, strictly speaking, the set of all prime numbers does not exist as a first-class object in Pinot arithmetic, right? You do disagree with Zenlin, for the record. So you're saying functors have to go in coach? Yeah. It's sounding like you and Arad are right. Well, I suppose so. But actually, here's the other question. I don't think you're here in this part, but asked both you and Arad, and you don't have to answer now in the comments. You can answer in the comments afterwards in the video. But I'm curious as to then what your opinion is of the purpose of the axiom of introducing growth in Deke universes at the very beginning of the infinity category textbook. But let me jump ahead. I'm going to jump ahead to my final point now. How do we define a category in Lean? How does one define a functor? How does one define a functor in Lean? Because generally one has, in type theory, one works with universes. And in fact, more generally, a hierarchy of universes. And how would one, if we had sort of all sets as being U1 objects, how would one formalize either the definition of a category or a functor in type theory, in Lean? How to actually construct that object in the computer. And I believe we would have to go to U2. So I'm jumping ahead to this. You're not a set theorist, obviously, but as far as you know, they constantly use proper classes. Yep, this is true, without a problem. I agree. I also don't have a problem with proper classes. And in fact, the set theorist I was talking to, as I showed earlier on stream, mentioned this. Set theorists work all the time with proper classes. Absolutely. First few pages of Yek, he doesn't seem to have an issue with classes working in ZFC. Yek or Herbachic in Yek? Which book by Yek? Which book by Yek? Not necessarily in many cases, yes, but in other cases, we need to be careful. See Scott's trick. Your recent work on solving deep question. Okay, I look forward to reading the Annals paper. How would one formalize a definition of truth within ZFC? Truth is also not a first-class object. That's fine. Yeah, that's fine. And I don't have a problem with things not necessarily being a first-class object. Yeah. And that's okay. One can have things that aren't first-class objects, but that's totally fine. That is totally fine. I have no disagreement there. You can have first-class objects. But is truth really being like, you can do things with formulas. You can do things with formulas, right? But you can't prove that, for example, you can't prove the set of all prime numbers exists in Pinot arithmetic as a first-class object, right? Type theory builds on a whole new meta theory to begin with. Sure. Your contention was that you can work with quite a lot of category theory with just ZFC. Okay, so if that's your only contention, then I agree with you. Then I agree with you, Leo. Then I agree with you. Subject to what was said here. Subject to what was said here. And you'd argue against things like the inability to work with schemes or HOM. I don't think I ever said that there is an inability to work with schemes. I don't think I ever said such a thing. Or defining functors between vector spaces. So again, the contention is, what do we mean by define? What do we mean by define? Right? If it is define, if for you, when you say define, you mean write down some formula that describes what the functor does, sure. I'm very happy for that to accept that is possible. If you mean but that is not the same as having a functor be a first-class object. Now, it is possible to have a category theory within ZFC where a functor can be a first-class object, subject to the constraints that are here. Arad and I never said that we constantly said the collections aren't set. Okay. It's nice to have all these heroes learning the super duper hard math, set theory, and logic to make sure that the rest of us are not spitting out nonsense. Is that true, or is it all in vain because we just do what we're going to do anyways? Okay, so here's the thing. Part of the issue was that when I think of the word define, okay, when I think of the word define, I'm thinking construct as a first class object, right? And so under that interpretation of the word define, then no, you can't in the ordinary sense, unless of course we take the caveats that are on screen. So with the way that I normally think of the word define, no, you can't. With the way that you're thinking of the word define in terms of describing this formula that articulates what the functor does, then I agree that you can. When you work in PA, you're not a number, you're a mathematician. Yeah. This is all absolutely philosophical, though. Yeah. We work with proofs constantly, which are basically never first-class objects. Unless you're doing type theory, baby. Unless you're doing type theory, then so maybe the whole takeaway from this discussion is that everything should be done in lean. So if you're in type theory, I mean, a proof is just a term of a type. That's all it is. That's a first-class object if I've ever seen one. Zen's answer is not quite right, or at least he's being criminally unspecific. Zen is basically claiming you can't really do anything with set in ZFC. Is that what he's claiming, though? Well, I guess Yumi and Arad, I guess we'll always just think that the other is wrong for the rest of time then. And maybe we should avoid all discussion of this in the future. How do I go see how category is defined in lean? I mean my point is this, is that in order to actually define a category in type theory, you got to go beyond the U1 universe in order to actually instantiate it in the computer. Okay, yes, I agree we can do stuff with formulas. So maybe we should put it all behind us now. That much I can agree to. That much I feel is uncontentious. I will just say one thing, and this is actually not quite orthogonal to making point what you can do in set theory by referencing type theory is a very silly argument. Well, but I mean, analogies are useful, right? Good. As long as the three of us have our guns pointed at each other, you need to find a way to this is us. This is so us. This is so us right here. Where is it? Well, where's the actual showdown? Where's that part happen? Oh, it's over here. Where's the actual showdown part? What the hell? Where they're all staring at each other and they're like, diddle-doo, doo, doo, diddle-doo, doo. It's not the final. It's the. Here we go. Final duel. That's what we wanted. Obviously, I'm Clint Eastwood. Dibs on the good. Oh, you said dibs before I said that. Fine, I'm the bad. That's right. I'm the bad boy in mathematics. That's what they call me. They call me Hans Niemann, the bad boy of mathematics. Skip to where they all kiss. With AI, we could easily make that scene appear now. Yeah. But I think referencing type theory is about as silly as referencing Pinot arithmetic. We're using analogies. We're using analogies to try and get our points across. But anywho, let's not see the part where they shoot each other because that's not how we want this to end. Okay, let me complain about this one thing. And this I don't think necessarily has a bearing because he says go look at how they define category of schemes. Yes, it's almost time to fight about number 3. I'll say this one thing though. I will say the page on classes in Stack's project is disappointing. Whether or not, no matter who of the three of us you agree with, informally we use the notion of class given a formula. We call this so here I think this is extremely loaded already because we're putting set braces around this thing that we're calling a class. But okay. A class is easier to manipulate than the formula that defines it, but is not strictly speaking a mathematical object. What? What? Okay. What? For example, this is a ring, blah, blah, blah. A proper class is a class which is not a set. In this way, we may consider the category of our modules, which is big, blah, blah, blah. Extremely short and disappointing. I think they go on to fix it when they do define the category of schemes, and they do it with this hierarchy of set universes or whatever. And then I think there's this extremely valid comment here. You say in this section that a proper class is a class which is not a set, yet in the previous section, the declaration was made that everything is a set. So is the set of proper classes an empty set? And if so, then what is the use of defining a proper class? If it is not true, then I think we readers are owed a little more explanation of the term proper class. Note the word informally at the beginning of the paragraph. Yeah, sure. Okay. But then at the end, okay, starting now, I'm going to delete comments on this page as it seems to track comments which are not at the content of the Stacks project at all. Yeah. I don't know. Raymond said we are all stupid idiots for cutting the genus G surface in half and not doing by induction? Really? Oh. So you and Raymond one-on-one fight? You're not disappointed that's exactly the type of class you were talking about. The book you were talking about is Yek. Yeah, but you said Yek. There's several books by Yek. Which book by Yek? Which book by Yek? Set Theory? By Yek? Because there's an introduction to set theory by Herbatrick and Yek, and then there's of course head empty set. Please come in and start arguing. I thought we were almost done. Where's the book where they all kiss? I'm writing it. I'm writing it right now. Just Yek set theory. Okay, well that's loading. Let's abandon that. let's try to talk about a little bit of number theory in the waning moments of this live stream. What am I looking up? Art and L functions, baby. Art and L functions. We're gonna look up more about art and L functions. An informal definition. Yeah. I don't know. I guess. What can I say? I hate informal definitions. Do I? I say informal stuff all the time. Usually, an informal definition usually leads to a better formal definition, which apparently doesn't exist. I think it does. I just think, I don't know. I think what that person said were owed a little more explanation than this one paragraph. Yeah, I think, yeah. Though you wouldn't be surprised at all if they introduce it in the same way. Yeah. If you recall, Yek doesn't say basically anything at all about classes and sets, and so won't be of much help. There was a book where they all kiss should be a sound on a soundboard. Yeah, how do I make a soundboard? I should make a soundboard, and Leo, you can send me a voice clip of them saying that. Well, this document's not going to open for the next 4 years, so... Where it's Canada where you are? Yeah. Well, we're taking over. That's actually slowly how we're invading the States right now, is by using our snow, because anything that the snow touches is Canada. So, yeah. So, in the winter, our empire expands. 4 years? I guess we need to dig in trenches. You can't defeat us in the snow. Yeah. In the summer, yeah, you could take us, but you can't defeat the Canadians in the winter. It's impossible. Now I can read about mice. What? Will I have Yek open? What? Anyways, on to L functions. Russia be like, yeah, they're trying to steal our strategy, actually. They've built their own HARP weather machine to try and steal our strategy. Control F mice? What? On this page? What are you talking about? What are you talking about? I mean, Yek's not opening for the next 3 years. That's taking too long to load. It's a rule of the universe. Must read about mice when you open Mac. Yek. K took such a big L that he's now reading about functions. In my mind, I'm the winner. Yeah. No dork in Yek. But Yek isn't open yet. See, it says opening. It says opening document. What are we gonna... Control F mice. See, nothing happens because the document's still opening. Hello, Locke. You missed it and we're not filling it in. Well, it's recorded on the internet for all to see. I mean, forward this video to all your set theory friends. Forward this video to all your set theory friends, and please get them to comment. You have no idea what's going on, so you shouldn't agree with anyone. I know you are, but what am I? Yeah. We were on yesterday's set theory issues. We're trying to move past it slowly. The set theorists will say we're all wrong. Hopefully. Category theory people have set theory friends? Necessarily. Yeah. Yeah. They're hopeless without set theory friends. Category theory people have friends? Well, each other. You made it back. Welcome back, Quen. What's the fun arguing when we know what we're talking about? Yeah, I don't know. I still disagree. And I don't know. I also I think this point in like I think bringing up the way that things are formalized in lean is not all that crazy, because like let's imagine, like, it's not so crazy to also imagine a set theory based proof assistant, right? And again, how would you actually instantiate a thing as a set in a set theory based proof assistant, in the same way that everything in type theory is a type? Um, your opinion is that the foundation of mathematics is philosophical endeavor. We shouldn't hold it to the same standards of rigor as mathematics. Well, that's just like your opinion, man. Based proof assistant, yeah. Set theory based homotopy type theory. We could. We all switched to homotopy type theory and stopped complaining. That could be good. That could be good. Although I still do have questions about homotopy type theory in terms of like, and actually, here's an interesting philosophical question, right? Here's an interesting philosophical question. You know, I suppose we have the statement. Right, we have the statement of Fermat's last theorem, right? Interpreted as a statement of set theory, right? Interpreted as a statement about set theory. So here, X, Y, and Z are elements of the set Z, right? But now, suppose I write down what is seemingly the exact same statement. But I write something like this, right? Of course, I'm not being super formal here, but I write something down like this, where now, what's the difference? These belong to the type. These belong to the type of integers. Are these the same statement? I mean, strictly speaking, if we're being as literal as possible, no, because one is a statement about sets, and the other, Leo, all of my writing could use a lot of work. What are you talking about? My Z could use a little work. All of my writing needs a lot of work. Strictly literally speaking, these are not the same statement, right? But here's the thing. Same in what sense? I mean, one thing is a statement about sets and one thing is a statement about types, and sets and types are not the same thing, right? How does one even compare them? How does one even compare? So actually, you could say, is it even meaningful for me to, you could even say, is it even meaningful for me to say that these are not the same? Because I would have to somehow define what it would mean for them to be the same in order for them to not be the same. In order to make this decree that they're not the same, right? But sets and types are just like, you can't. How do you talk about these things? And well, maybe even we could talk about the PA's version of this statement. Yeah. So this is the interesting thing, though, Arad, right? You can model fragments of set theory inside type theory and vice versa, but they are different beasts. Yeah. So I don't know. I think this is an interesting point to think of. I mean, clearly they are, right? And like clearly, the steps of the proof. I mean, we could let's take something less lofty, right? Let's take the irrationality of the square root of 2, right? Because I can imagine maybe for what I'm about to say, there's other technicalities that come up here, but let's say the proof that the square root of 2 is an irrational number, right? Not only is it like quite obvious how to formulate this statement, both in ZFC and type theory, right? And somehow they should be the same, right? Like somehow the type theory version and like the ZFC version are like clearly this is the same statement, right? In some sense. But how could we ever be precise about this? Like Arad said, there's ways that you can model fragments of each other inside there, but I also don't think like, is there like a canonical way to do this? Not necessarily, right? You don't think XQ is a type theory thing? Yes, it is. Holy 2, yeah. okay, yeah. I mean, it's pretty bad. Whatever. But even beyond these statements being the same, obviously even the proofs are somehow, it's very tempting to say the proofs are the same, right? Because like you could follow the exact same steps, the exact same like proof by contradiction or whatever that you normally do. So it's like even somehow the proofs are the same. Every type theoretic proposition determines a usual FOL, first order logic proposition. I think, are you talking about homotopy type theory, Arad? I'm not necessarily talking about homotopy type theory, although that's the next thing to say. Then, yeah, because I thought mere propositions are just mere proposition. You're talking about taking pi 0. I mean, that sounds a lot like homotopy type theory to me, which is also the other level up, because now, and this is maybe more just my ignorance about it. So already there's this weirdness about like how exactly do we transport statements which are somehow like obviously the same, going back and forth between these, right? And then oh sure, you're right. It should be represented as the type is rational square 2. You're right, Locke. You're right. But then what am I saying? Right, but then so already there's this question about ZFC versus type theory. But then we come to this question of like ZFC versus homotopy type theory. And now things become even weirder once we have univalence, right? I like there's some part of me that believes it's even less obvious now. And I mean, what Arad says is true. We can pass to mere propositions, and stuff like that. And in order to get sets, which sets are basically what propositions are like the 0th level, and then sets are at like the 1 level, and so there's some way to embed it in there. But then like we're not dealing with just sets. Like when you prove the fundamental group of the circle is the integers in homotopy type theory, which is basically by like definition, I mean, to me, it's less obvious. Like, on one hand, it's obvious that this is the same statement as it is in ZFC. And yet, if you think about, like, how we would literally transport this equation across these worlds, it's not. I don't know. It's a weird thing to think about. You can't define connectedness in first order logic of graphs? I didn't know that. Why is that? Why is that? You can't define connectedness. Because you're quantifying you're quantifying over the entire vertex set or something? Because you're saying like for all x and y, like there exists a path between them? Not is, well, I think it's like something like p implies false or something, like, which is it's like the arrow type. Or I guess it's like the arrow type p into false or something. That's like not p, right? Isn't it something like that? Well, let us know when the blog post on Church-Turing drops. Yeah, it definitely seems like it's a long list from all the things you've dropped. But how'd the 8 hour stream go? It was good. It was good. I was hoping we would raise a little more money for the kids, but hey, I mean, we didn't do bad. We made more than minimum wage, so it was still more worth my time than to just go work at a coffee shop for 8 hours and donate that. Yeah. Type theory and set theory have a whole different take on what truth even means. Oh, I guess I need to look more into what truth even means in type theory and in set theory, I suppose. You and your ex also have a different take on that. Yeah. He was a site theorist. He was a set theorist. She did type theory. What more can I say? You do remember some discussions on overflow of ZFC versus hot, yeah, on their equiconsistency or something. So you're also getting to like Platonist questions, I guess so. Yes, you should learn some hot diffeomorphic. Can I copy that? If I copy that and then I go to the URL. Wait, what do I type in? Math Stack Exchange? What if I just type in the end part? For example, the early people who worked on topological spaces like Urshan wondered if they were wasting their time. I wonder that all the time too. Maybe we would take a type theory without universe hierarchy and see how far we can get through categories for the working mathematician. I don't think we can get very far. I don't think we can get very far. But I would be interested to do it. I would be interested to do it. Let's tomorrow on stream. I could download Lean and I'll download categories for the working mathematician and we'll see how far we get. Results like Gaga are one of the things that make you think we're working with the right objects. Can you expand on what you mean by that? Actually, expand on what you mean by that tomorrow, because I think I'm going to go right away. The only issue would be instantiating the analogous categories that run into class issues in ZFC. So maybe category of types. You can't define connectedness because you can't quantify overall arbitrary sequences of points, right? Maybe his feeling was a prediction. A lot of early point set people, yeah. In a proof assistant, you'd agree you meant more like working abstractly in the meta theory of a type theory, like we're doing with sets. I mean, I think either way, right? Whether you're writing it on paper or in the proof assistant, I think you might run into issues pretty soon if you don't have at least one extra universe. Oh, the question is, why is this the right axioms for a space? Yeah. Well, I mean, yeah, lots of people in hindsight have the opinion now that we did not have the right axioms of a topological space. Quick tangent, if I don't mind. You're thinking about getting back to studying enough to get back to pure math on the side after 3 years of not doing it. You're not sure what to begin with, though. I don't know what to suggest for you, to be honest. Yeah, I don't know what to suggest. Yeah, what are you interested in? That's all I can really say is, yeah, pick what you're interested in. I don't know. Where did you leave off? And it depends on what exactly you want. Are you just doing it for fun? So yeah, I don't know. I don't know what to say. Representation theory, obviously. Or how about logic and correct us all in our wrongness? Part of condensed math is saying topological spaces are ass. Yes, exactly. And let's make them compactly generated. Yeah. Yeah. Drowning. Irishon drowned. Goddamn. You don't know enough about meta theories to know what a meta theory of type theory looks like. Well, new learning goals unlocked for all of us. Damn, we all gotta let's make sure we get funding for mathematicians and physicists to get swimming lessons. You can define abelianness in first order theory of groups, though. Ah, really? You don't have to quantify overall things? Maybe somehow. Yeah, that's interesting. Lean 4 has universes. That's not what you'd want. Yeah, but you could still, I mean, whether you're doing it on paper or whether you're doing it on paper or in Lean, like, you could just not appeal to the universes, even though they're there, right? Look at the series on MIT OCW. Oh, OpenCourseWare. For all AB equals BA. Wait, then I guess I'm confused about why that's okay, but not all paths in a graph is okay. Is not okay. Anywho, that's where we're going to end it today. Who knows what we'll talk about tomorrow. Maybe we'll learn some type theory tomorrow. I don't know. I don't know. Yeah, so I guess what I don't understand is why we can't quantify overall sequences of vertices, but we can quantify overall elements of a group. So maybe we should try and understand that tomorrow. Okay, there's all of these interesting questions, but I gotta go. Oh, you finished all that stuff? Okay, well, Quen, maybe, I don't know, comment on the video afterwards. I will comment in the video afterwards. Maybe I can suggest some things or something, or maybe other people can. But I'm gonna go. It's been a long office hour, not as long as yesterday though. So